Welcome to solverfy.
Okay, so we're doing chapter 23, problem 37 here. So we have a 12 centimeter radius thin ring which carries a uniformly distributed charge of 15 microcoulombs. And it says a small 7.5 gram sphere with a charge of 3 microcoulombs is placed exactly at the center of the ring and given a very small push so it moves along the ring axis. So we have our ring here, we have our little sphere, and it gets pushed along this x-axis. And we want to know how fast would the sphere be moving when it is a distance 2 meters from the center of the ring. And of course it says ignore gravity. Okay, so first we should know, if we're talking about distances and speeds here, this might smell of an energy problem where we use energy conservation. So if we use energy conservation, we should know that the initial kinetic plus the initial potential is going to be the final initial plus the final kinetic. Okay, so when the ball's initially in here, what's its speed? Well, its speed is 0. So initially the kinetic energy is 0. Okay, so now let's figure out what the initial potential is. Well, what does this equal? The equation for potential the electric potential energy is the product of the point charge and the electric potential at the location of the charge. So if we're trying to find the electric potential of the sphere, we know we take the charge of the sphere times the potential of the ring. So this becomes Q sphere times the voltage of the ring, which we know is given by dq over 4 pi epsilon naught r squared plus x squared. Okay, so if we do this for a uniformly charged sphere, then this comes out easily to just being Q sphere times the Q of the ring, because this only depends on Q right here, so all of these are constants, and we're left with this. So this is U as a function of R and X. Oh, R is a constant, sorry, this is just as a function of X. Little r is the radius of the ring here. Okay, so in that case, U naught would be U naught is U as x equals 0. U final is U at x equals 2. So let's plug these in, and this becomes Qs times Qr over 4 pi epsilon naught r. Okay, and this one becomes Qs Qr over 4 pi epsilon naught square root of r squared plus 4. Okay, let's plug things in now, and we should see that U naught equals U final plus 1/2 V final squared. Let's rearrange and see that V final is given by U naught minus UF all times 2, all divided by the mass, and all square rooted. Okay, so our V final then becomes square root of 2 QS QR over 4 pi epsilon naught R minus 2 QS QR over 4 pi epsilon naught square root of R squared plus 4. And this is all divided by the mass. It's hard to see there. So we can just plug things in now. So this is the square root of 3 microcoulombs times 15 microcoulombs all over 2 pi times epsilon naught times 12 centimeters minus 3 microcoulombs times 15 microcoulombs all over 2 pi epsilon naught square root of 12 squared plus 4. And this is all divided by 7.5 grams. Cool. That's a lot of stuff in your calculator, but if we plug it all in, this comes out to being roughly 29 meters per second. Awesome.